Morning, afternoon, evening, from wherever you're watching. You're welcome back once again to the Making Masters, a channel solely dedicated to demystifying mathematics, making complex things easy. Today we'll be looking at the number-based system. And what do we mean by the number-based system? The number-based system is generally a system of counting numbers. When we talk about counting, there are different base numbers. You can have base 10, base 2, base 8, base 7, and so on and so forth. In the number-based system, certain units make up a bundle, and that bundle that they make up gives us an idea of the place value of that number system. Normally, counting generally is done in base 10, and base 10 numbers are also known as decimals or denary numbers. For any number-based system, the highest digit of or in that system, in that number-based system, is 1 less than the base system. For example, if I'm in base 10, the highest digit I can get is 10 minus 1, which is 9. If I'm in base 7, the highest digit I can get is 7 minus 1, which is 8. So if I'm in base X, the highest digit I can ever get is X minus 1. So for every number base I am in, the highest digit will be 1 less than the base where I am in. Now let's look at writing numbers in expanded form. Writing numbers in expanded form. For example, let's take example 1. We are asked to write, because this expanded form will allow us to understand the number-based system properly. For example, I'm giving an example. Write this number 5431.231 in expanded form. Now, if you see a number like this, if nothing is written here at the down part, it tells us that that number is in base 10. It's in base 10. Now, for me to write it in a expanded form, first I must understand the place value. This first one here, this is the decimal point. The decimal point, after the decimal point, the number, the first digit is what we call a tenth. Tenth. A tenth. The next one is called hundredth. Hundredth. With a th. And the third one is called the thousandth. Now, before the decimal point, the first digit there is called the ones. The ones, or we call it the tens. 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 The ones or the units. The ones or the units. Why the next one here is called the tenths. So the first one here is called the ones. This is called the tenths. This is called the hundred. And this is called the thousands. Thousands. Now, that's why this number is pronounced 5,000, because under the thousand part you have 5. Under the 100 part we have 4. That's why we say 5,430. These tens, 3 tens means 30. 3 times 10, 30 and 1. That's why this number will be pronounced 5,431. That's this part. Now, having known the place value, if you want to write it in expanded form, 1,000 is what? It has 3 zeros. That means 5 times 1,000. This is 1,000. 1,000 has 3 zeros, 1 and 3 zeros. So plus 100 has 3 zeros. This is 400. That's 4 times 1, 2. Sorry, 2 zeros rather. 100 has 2 zeros. Thousands has 3 zeros. Plus the tens has 1 0. Under the tens part here is 3. So 3 times 10 plus the 1 here has 1 times 10 raised to the power of 0. We put it like that because anything raised to the power of 0 is 1. So we are done with this part that is not the decimal part. We move to the decimal part. This one is 10th. That means 1 over 10. The first part there is 10. 1 over 10. So we say plus 2 times 1 over 10. Because this is the 10th part. 1 over 10th. Now plus 3 times, this is the 100th. This is 1 over 100 plus the last one is 1000. That will be 1 over. Now from here, this is 1000. I can write 1000 in index form. That's 10 raised to the power of 3. So we'll say this is 5 times 10 raised to the power of 3 plus 4 times 10 raised to the power of 100 has 2 zeros, so raised to the power of 2 plus 3 times, this is like 10 raised to the power of 1. 10 raised to the power of 1 is that number. 10 raised to the power of 1 is 10. So 10 raised to the power of 1 plus 1 times 10 raised to the power of 0 plus, now this 1 over 10, I can rewrite it as a negative index. That will be 10 raised to the power of negative 1. 10 raised to the power of negative 1. This one will be 10 raised to the power of negative 2. And this one will be 10 raised to the power of negative 3. If you continue again, it will be 10 raised to the power of negative 4 and so on. So this is 2 times 10 raised to the power of negative 1 plus 3 times 10 raised to the power of negative 2 plus 1 times 10 raised to the power of negative 3. So I've ended up writing this number in expanded form. I've expanded it. This is the number. I've expanded it using the place value. The place value system. So when you are talking about the number based system, you must understand the place value. Alright, let's take example 2. Still under writing numbers in expanded form. Now the first number example we dealt with was in base 10. If we have something like this, let's say 453.134 base 8. I can be asked to put or write this number in expanded form. This is in base 8. So the first thing we will do, we are going to put our power. From here, you have 0, 1. That's another way of doing it. 1, 2, 3. Then after the decimal point, I have negative 1, negative 2, negative 3. Now I've written the powers. So the first thing I will do, I will say 4 times the base, which is 8. The base we are in 8. So I will say 4 times 8 raised to the power of 3 plus the next number 5 times the base, 8 raised to the power of 2 plus 3 times 8 raised to the power of 1 plus 2 times 8 raised to the power of 0 plus, now we are done with the whole number part to the decimal part or the fraction part, plus 1 times 8 raised to the power of negative 1 plus 3 times 8 raised to the power of negative 2 plus 4 times 8 raised to the power of negative 3. So we have ended up expanding this number in base 8. Now we can take another example. Let's look at another example in another base. That's the same way we are going to do it. Now, for example, I have something like this. Expand this number 785.324 in base 9. Like I was explaining earlier, the highest digit you can get in a base is 1 less than the base. So for example, now that we are in base 8, I cannot have the digit 8 in this number. That's the meaning of that, of what I said earlier. If I'm in base 9, I cannot have the digit 9 in this set of numbers, in this set of digits. So the highest power of any base is 1 less than 8. So the highest digit I can see in base 9 is 8. So the next thing we do, let's expand it by putting the powers. The first one will be 0, next one is 1, next one will be 2. Then after the decimal point, just like your number system, positive, negative. Negative numbers will be at the decimal point, the side of the decimal point. So this becomes -1, -2, -3. So this will be 7 times 9, the base, raised to the power of 2, plus 8 times 9 raised to the power of 1, plus 5 times 9 raised to the power of 0, plus 3 times 9 raised to the power of -1, plus 2 times 9 raised to the power of -2, plus 4 times 9 raised to the power of -3. So we've ended up expanding these numbers. All right, the next thing we'll look at converting numbers from base 10, to any other base. Now, let's take example. Convert 124 base 10 to a number in base 8. So we can convert numbers from different base, from base 10 to any other base, from the other base to base 10, and we can also convert numbers from one base to another base other than base 10. But first, we'll look at converting numbers from base 10 to any other base. So let's look at this first example. Convert 124 to a number in base 8. The first thing we have to do is successive division. When we are converting a number from base 10, take note, we divide successively. So I rule, this is 124. We divide it by the base in which we are going to. That's base 8. So this is 8. 8 in 124. That will give us 8 in this. That's 1. Remainder 4. 8 in 44. That's 5. 8 times 5, 40. That's remainder 4. 44 minus 40, that's 4. Now we use 8 again. 8 here, 1. Remainder 7. That's 8 times 1, 8. 15 minus 8, that will give us 7. And the next thing, we use 8. 8 in 0. How many 8 can you find in 1 rather? None. We cannot count 8 from 1. So we write 0. Our remainder will be 1. So now this is what we do. After you have divided it, we read the answer upwards. We read it upwards, down to up, from the base point to the apex. So always remember, we read it downwards, upwards, down to up, if there's any grammar like that. All right. So therefore, 124 base 10 is equals to 174 in base 8. So 124, we have ended up converting a number from base 10 to base 8. All right, let's take another example. For example, example 2, you can be asked to express 437 base 10 to a number to a number in base 5. So we are going from 437 base 10 to a number in base 5. The same method, successive division, we divide it by the base we are heading to. So solution, we have our 437. This is base 5. Now 5 in 43, that's 8, because 5 times 8 is 40. Remainder 3. Remainder 3. 5 in 37 is 7. But we have a remainder. Remainder 2. Because 5 times 7 is 35. 37 minus 35, 2. That's the remainder. So we have this 5 here again. 5 in 8, that's 1. Remainder 3. The same thing, 5 in 37, that's what, 7. Remainder 2. Now 5 in 17, that's 3. 5 times 3 is 15. 17 minus 15, that's what, 2 still. Now we have 5 in 3. Can you see 5? Can you count 5 from 3? Can you remove it? No. So that's 0. It's not possible for 5 for us to count 5 from 3. So 0 remainder. The 3 still remains 3. Now the next thing we do, don't forget, we'll read it downwards, upwards. So down, up. You draw your arrow so that you don't make that mistake. Some students might have make the mistake of reading it downwards, upwards. And in some exam scenarios, you will see this answer there, 2, 2, 2, 3. So don't make that mistake. It's from down to up. Now, therefore, our 437 base 10 equals to 3222 base 5. 3222 base 5. So don't forget, we can also convert this number from base 5 to base 10. We can convert it. You can use it to check if your answer is not correct, but we'll get there. Let's take the last example in this section. Example 3. Express 4, or let's say 538 to, in base 10 anyway, to a number in base 2. Okay, base 2, which is also known as the binary base system. Now, for us to express that number in base 2, the same thing, the same pattern in which you have been doing, we divide by the base you are heading to. So this is 538. We are heading towards base 2, so you divide by 2. Now 2 in 5, that will be 2. Remainder 1. 2 in 13, that's 6. Remainder 1. 2 in 18, that's what, 9. Remainder 0. You put it there. In base 2 system, you only have 2 digits, 0 and 1. Now we go again. 2 in 2, that's 1. 2 in 6, that's 3. 2 in 9, that's what, 4. Remainder 1. Because 2 times 4 is 8. Remainder 1. Now let's go again. 2 here. 2 in 13, that's 6. 6 times 2, 12. 13 minus 12, 1. Remainder. So 2 in 14, that's 7. Remainder 0. Let's go again. 2 in 6, that will give us what, 3. 2 in 7, that will still give us 3. Remainder 1. Now let's go. 2 in 33, 2 here. 2 in 3 is what, 1. Remainder 1. 2 in 13, that's 6. Remainder 1. We'll go again. 2 in 16, that will be 8. Remainder 0. 2 in 8, that's 4. Remainder 0. 2 in 4, that's 2. Remainder what? 0. 2 in 2, 1. Remainder 0. And the last one, 2 in 1, you cannot count 2 from 1. That's 0, remainder 1. What's the next thing to do? Your guess is as good as mine. We'll read it downwards, upwards. Now, so therefore 5 3/8 base 10 equals to 1 0 0 0 0 1 2 3 4. Okay, 1 2 3 4, yes. 1 1 0 1 0 base 2. So we have ended up expressing number from base 10 to base 2. So don't forget, when you are going from base 10 to base 2 or any other base, you divide successive division by the base you are heading to. All right, I hope we have learned today. If you see a number or we are asked to convert from base 10 to any other base, we know what to do. Successive division. All right, in our usual style, this is our list of take-home fun. Practice it. The first one says convert these numbers in base 10 to base 6. The first one is 9054, 9054 in base 10 to base 6. The other one, 803 base 10 to base 6. So you are dividing by 6. Next one, convert these numbers in base 10 to octa. Octa is numbers, or they are numbers in base 8. So octa means 8. So don't be confused by that. 8005, 1073. I hope you have learned. Put the answers of the take-home fun in the comment section. Solve it, let me see. And if you have any issue in mathematics, do let us know. Any area, any aspect of mathematics you are confused, or any question, put it in the comment section. Or any topic you want us to tweet, put it in the comment section. Till we meet in the next class, remember, learning is fun, mathematics is fun. Keep practicing. Bye bye.